Welcome to this Cycon machine learning tool tutorial. In this session, we'll focus on multi-class, multivariable classification using the Histog gradient boosting classifier. Our case study comes from network logs dataset, where the goal is to classify different types of scans based on encoded log features. This slide provides a summary of the network logs dataset. Each record in the dataset describes a network communication, represented by features such as source IP, destination IP, port, request type, and protocol. These features capture the essential details of how devices communicate across the network. Together, they form the input variables that we will use to classify the type of network scan. Here, we highlight the distinction between input features and the target variable. The input features are the log attributes: source IP, destination IP, port, request type, and protocol. The target variable is the scan type, which identifies the category of network activity. Examples of the scan type include port scans, service scans, or ping sweeps. The goal of the model is to map from a multivariable input data to the correct scan type class. Now, let's talk about the histogradient boosting classifier. It is an ensemble method that builds decision trees sequentially, where each new tree is trained to correct the errors of the previous one. The histogram approach means continuous features are efficiently binned, making the algorithm highly scalable to large datasets. Predictions are made by combining the weighted contributions of all trees in the sequence, and the final class is the one with the highest aggregated score. Finally, we move to the training and evaluation phase. We split the dataset into 80% for training and 20% for testing. Histog gradient boosting classifier is trained on the training portion and then evaluated on the test set. For performance, we use F1 score, which balances precision and recall. This ensures the model is not only accurate overall, but also reliable in detecting each scan type class without bias. The workflow is straightforward: train the model, predict the scan type, and evaluate with the F1 score. Now let's move on to how to use Cycon machine learning tool web page to implement this model. First, let's name our model, and then let's write a brief description of our model. On the data type drop-down list, let's choose tabular, since our data is in CSV format. And then let's click Upload CSV and click this Upload button. Let's click this CSV dataset and click Open. After successfully open the dataset, we'll see the brief summary of the dataset on the right side. The Table tab gives the list of all of the columns of this dataset. And then if we click the Data tab, it gives us a summary of the no instanced data types of each columns and unique values of each columns. Now let's move on and select the target column, which is the scan type. And then we click Machine Learning Algorithm. In the end, let's choose our classification model. And then let's choose our evaluation metric, which is the F1 score. Finally, let's click Perform. After a few seconds, we'll get the evaluation result, the F1 score. It is very accurate. Its accuracy shows that the model was able to almost perfectly predict the values with the input features. Thanks for watching.